Our final speaker in the industrial section comes to us from TÜV SÜD. He is an expert in additive manufacturing and is working on the challenges to industrialize additive manufacturing. In particular, he's committed to the reproducibility, scalability, and safety of additive manufacturing machines. Please welcome Christoph Vehring.
Yeah, thank you very much. So today I want to talk about guiding towards industrial additive manufacturing readiness. But actually, why do we talk about guiding? It's because at TÜV SÜD, a global testing, inspection, and certification company, we think we haven't achieved the industrialization in additive manufacturing at all so far. So what's the problem within industrial additive manufacturing? It is that we are missing standardized quality assurance for safe and reliable products. As you can see, on the base are the today existing standards. They are very general quality requirements. For example, the ISO 9001 as a general, ISO 13485 for medical, and ISO 9100 for automotive. But they don't mention additive manufacturing at all. Especially if we want to get to the top, where we can see the product testing, which is quite relevant in additive manufacturing right now. As we've seen in the session before, for example, in aerospace and also automotive, it's quite important if you produce 1 or 2 parts in aerospace, or even up to 100 in automotive. You have to qualify each part. It's most of the times 100% qualification process. So our mission as TÜV SÜD is to make the implementation process more efficient with a standardized certification based approach and digital quality assurance, which I will get on to later. So what have we done? We have built up onto the general quality requirements with a so-called production site certification. Here, we work together with OEMs, with end users, with machine manufacturers, and basically all stakeholders within additive manufacturing to define the quality and also the safety requirements that a production facility has to have. Because at some point, especially now and a few years ago, there are more and more service providers coming for AM parts, right? And just having a production facility and placing some printers there, like 4 printers, doesn't mean you can achieve industrial additive manufacturing, right? So that's why we sat together with the stakeholders and defined the production site certification. But actually, what is this about? I can explain this the best way through the Deutsche Bahn. Susanne already mentioned the business case of the Deutsche Bahn. It is producing spare parts for the trains. And especially not they are producing, but their service providers are producing. So Deutsche Bahn has to make sure that they are provided by high quality and safe parts. How do they do that? The normal way would be that an OEM, if it's aerospace, automotive, medical, or any other industry, they define their own quality requirements. But often they lack of AM-specific quality assurance. So that's why, like I said, we defined the quality requirements on our own. And now we test the service providers if they fulfill the quality requirements. So Deutsche Bahn can make sure, and actually demands right now, that the service provider has to have a production facility certification so they can make sure they are getting high quality and safe parts and don't have any additional qualification expenses. But actually, what is tested? You can see it to the right. at first, the corporate management is tested. So what does the service provider want to achieve with additive manufacturing? Second is customer management and order management. This is about how does the service provider handle a customer inquiry. And then the most important two stuffs are production management and additive manufacturing. Here we look specific into detail. We look at how is the data handled, how is the powder or as a whole the material handled, how are the machines pre-qualified for the production of a specific part, how do they choose the process parameters to be the right ones, and to the extent that how can they ensure high quality within post-processing. And we not develop these quality criteria on our own, but we also translate it back to the international standardization. So that's why below you can see we have a standard based on this, which is discussed on international level. And already a few companies, or 5 companies to be exact, have professed to producing high quality and safe parts. Siemens, Toolcraft, Blue Production, Protec, and Evonik. And with this quality assurance fundamentals, the industry-specific requirements are manageable. But it doesn't stop there, because on the market we see that not even the hardware, for example, or the equipment and workflow itself is reproducible to this point. We always get in contact to customers and they say, hey, look, we had to have 6 months to qualify a specific part on a machine. And that's what we want to tackle with the following slide. So we want to enable AM hardware for regulated industries. So we as TÜV SÜD test the hardware against following test criteria, as you can see right again. Reproducibility, reliability, safety are demanding, and additionally usability and connectivity. But actually, how is reproducibility and reliability granted? We are demanding 5 test criteria, or 5 part specific criteria, which are, for example, geometrical accuracy, tensile strength and hardness, for example, and they have to print specimens, but not only on one machine, because it has to give the right results for the whole machine type, right? So at least on 2 machines, these specimens have to be produced, and then we will test the results, and the machine manufacturer can then present the results to his customer, and therefore ensure reducible results and also a reliable system. So that's what we thought so far, but just to give a quick outlook for the future, we have a digital part report for quality assurance. Actually, I've brought 2 parts with me. They have a QR code, and with this QR code, you can scan the part, and then you will get a digital part report, which lists all process parameters of the part while producing. It lists the whole life cycle of the part. For example, if it is a gear, it will be tracked when it was finished producing. And then, for example, you have to maintain it. You disassemble the gear, you scan it again, and then the maintenance process is also traceable. So it's a traceable thing, and for us as TÜV SÜD, it's easier because you can see or you can predict the quality based on the process parameters that you have tracked during the production. So that's basically our side of the future for testing, inspection, and certification. That's so far from my side. I would like to show you the parts in the end after this session, and thank you from my side.